Hey guys, this video is for page 36 of your interactive notebook about types of chemical reactions. In the types of chemical reactions activity that you guys did, you should have observed 5 distinct different types of chemical reactions. We're going to discuss all 5 of those on this page and also look at examples of each. So we're going to move from right to left, and after we talk about the type of reaction, then we'll go look at an example of it. So let's start with the first type, which is a synthesis reaction. As you might have inferred from the word synthesis, a synthesis reaction is a chemical reaction in which 2 or more reactants combine to form a single product. This is going to come in the general form A plus B produces AB, where both A and B are either an element or a compound, and they combine to produce a larger compound. An example of a synthesis reaction is the synthesis of water from hydrogen and oxygen. H2 plus O2, each an element, combine to produce a larger compound, H2O. The next type of chemical reaction is kind of the opposite of a synthesis. It's a decomposition. As you can probably also infer from the name, a decomposition reaction is a chemical reaction in which a single reactant decomposes to form 2 or more products. Generally, this will be some larger compound AB decomposes to produce a compound or element A plus another compound or element B. On the left side, our example of a decomposition reaction is the decomposition of hydrogen peroxide, H2O2. This larger compound breaks down to form a smaller compound, water, H2O, and the element oxygen. The third type of chemical reaction is a single replacement reaction. These are chemical reactions in which a more active cation or anion replaces a less active cation or anion. So we're going to have an element A plus a compound BC produces an element B plus a compound AC. And you'll notice here that A and B just exchange places. Now this would be the general form if we had a cation being replaced. But really, A could be a nonmetal replacing an anion, C. But we're not going to worry about that. We'll see some examples of that. So on the left, we're going to have a metal, zinc, combined with a compound, copper 2 sulfate. And because zinc is more active than copper, it's going to replace copper to form zinc sulfate and copper. A similar type of reaction is the double replacement reaction. These are chemical reactions in which the cations and anions of 2 different compounds, generally in aqueous solution, will switch to form 2 new products, and at least one of these will be a gas, a liquid, or a solid. And remember that solids that form out of aqueous solutions we refer to as precipitates. This will be of the form compound AB plus compound CD produces compound AD plus compound CB. And you'll notice that the cations have basically switched partners. So now A, instead of being bound to B, is bound to D, the original anion of this compound, and C, instead of being bound to D, will now be bound to B, the original anion of this compound. So on the left, our example is potassium iodide plus lead-2 nitrate, which produces lead-2 iodide and potassium nitrate. Again, you'll notice potassium, once bound to iodine, will now bind to nitrate, forming KNO3, and lead, once bound to nitrate, will now bind to iodine, forming lead-2 iodide. As it turns out, lead-2 iodide is an insoluble compound, and it will precipitate, which is what makes this a chemical reaction. We'll talk about that more on page 37. The last type is the combustion reaction. These are chemical reactions in which usually a hydrocarbon, and a hydrocarbon is any compound made of carbon and hydrogen, and sometimes it'll also have oxygen, react with oxygen gas to form carbon dioxide and water. So you'll notice that I have a hydrocarbon, CXHY, XY, and up here Z. These could be any number of different subscripts. There are a lot of hydrocarbons out there. So CXHY reacts with O2 to produce CO2 and H2O. And the nice thing about these reactions is they will always have the same products, carbon dioxide and water. And they're always going to be reacted with oxygen. So on the left, we're going to look at the combustion of methane, CH4. So CH4 plus O2 react to form CO2 and H2O. Like I talked about on page 35, we're still not balancing these yet. So you'll notice that all of these chemical reactions are unbalanced, and that's okay for now. We're going to worry about balancing them later. Anyway, if you've got this down, go ahead and practice this concept on the types of reactions worksheet, and when you finish that, glue it into the left side of page 36 on type of chemical reactions.